Okay, so before we move on, someone commented on the last video, what if we want multiple config providers? So let's say that in production, we want to read them from process.env, while in dev, we're going to read them from a .env file. How can we switch between the two, or at least provide fallbacks? So here's the problem. We're using layer.env, and what this is going to do is replace the default config provider, or well, whatever other config provider you have that comes before providing this one, which means that it is not going to read from the process.env. Instead, it is always going to try and pull them in from this path right here. So for that, you can use layer.env-add, and what this is going to do is add the .env config provider to the env as a fallback to the current provider. So if the file is not found, a debug log is produced and empty layer is returned. So this is how you can achieve support for the two. You would need to use this variant right here. But how does that work internally? Well, if I come here, as we can see, it uses from.env and it is going to get back the config provider. Now notice how this can fail. This can fail with a platform error, which is going to be represented as null because it uses effect or else succeed. So do this or else fall back with null. And so if it is null, meaning that the file was not found, then it is going to log debug and return an empty layer. However, if the file is found, it is going to retrieve the current config provider, which could be the default one or whichever other you defined, and then it is going to use this or else. So use the current one or else fall back to the .env config provider, and it returns a layer that sets this config provider. So this is how you can create your own fallbacks. If you need to support different sources, maybe a cloud-based solution where you need to make a request to pull in the envars, then this is how you would do it. You would prioritize the process.envars, or let's say dev, and then for your deployments or whatever, you would fall back to the other config provider. Anyway, while this works, this is not ideal because we need to ensure that at any place where we're going to read from the envars, we need to provide this exact configuration where we need to get the current working directory and then go 2 levels up to the .env. So we're going to do something different. We're going to get rid of this line. So now it is by default going to try and read the envars from the process.env, and instead we're going to use the dotenv-cli package. So what I'm going to do is add to the root as a dev dependency, so wd, the dotenv-cli package. And once we have this, we're going to go to the package.json of the client, and notice how we're already using .env here, but we're going to get rid of that dependency here since now it's a workspace dependency. So this is no longer needed. We also need to update it for the database. So .env no longer needed. And finally, we need to do it for the server. So .env, and we can get rid of this. Nice. So now, if we recall for the dev one, we already have .env. So we're going to copy this, and then we're going to go to the database and change the migrate to use .env. Same with reset, and same thing for the server. So this dev here, and I guess we could also add it here for start. So we can start the local build if we wanted. And I guess we're good to go. So now, by default, again, it is going to read them from the process.env. Now, one last thing is I want to apply a retry policy to PgLive so that if we fail to establish a database connection, then we can retry a fixed number of times with, say, an exponential schedule. And this is just so we can start understanding how we can work with layers, because I know a lot of people are pretty confused with the concept of a layer. As in, we know that an effect is a computation that can succeed with something, can fail with something, and can require something. But if you take a look at the signature for a layer, it is pretty much the same. So why do we have layers? Why can't we just do everything via effects? And that's because a layer is merely a constructor for services. And services require special treatment. And that is, you need to memorize dependencies. For example, if we were to have 100 consumers for PgLive, we wouldn't want to establish 100 different connections to the database. We only want one. But what if one consumer requires a fresh connection? Well, in that case, you could use layer.fresh to ensure that that consumer will get a fresh instance. So notice how these are things that an effect wouldn't really solve. So that's why we have layers. And there are obviously way more things to constructors. This is just the surface. So if we recall, PgLive can fail with SQL error. And this is a very generic error. It encompasses basically any error from the driver. It doesn't discriminate by type, let's say a connection error if I'm not mistaken, but that's okay. But the other problem is we get a config error here. Should we just apply a retry policy like layer.retry and then we intersect and we import schedule from effect, a recurse schedule of max 2 times with an exponential schedule? Well, if we do this, if the database URL is not in the envars, then this is going to be retried 2 times. So we're going to get a total of 3 attempts, which is obviously not what we want. Now, if you're wondering what this intersect is, well, this is basically AND semantics. So this one must pass and this one must pass. If, let's say, we have already retried the 2 times, then this is simply not going to pass. You also have union or semantics. So pretty straightforward. So how can we act on the error? Well, for that, unfortunately, the ergonomics for the input of schedules isn't the best. And what I mean by that is there's this schedule.fromFunction utility where you can pass in a function. And as we can see, we're going to get a no infer of config error or SQL error. So it was able to infer the type for us. Now here you might be tempted to check, is this a config error? If so, then stop the schedule, otherwise do the rest. But fromFunction doesn't allow you, or rather expect you, to return a schedule. You need to return B, which is a way for you to transform the input. So as we can see, it creates a schedule that always recurs, transforming input values using the specified function. And here, this schedule continuously executes and applies the given function to each input value, producing a transformed output. So you can't return a schedule here. So here you could try playing around with different values, maybe an option.sum or option.none, and then filtering out the output and whatnot. But once you start again combining everything with the different combinators, it ends up losing the type information for this error, and this will end up as unknown. Now this could simply be a skill issue. So if you know how to get this to work with fromFunction, do let us know in the comments. But what we can do instead is make it the more imperative way, where we can get self here, which again is the layer, and here we can say retry self, and then we can say schedule.identity, and for the type we can say layer.layer.error, and then type of self. And what is this identity? Well, if we come here, we can see that it creates a schedule that always recurs, so it doesn't dictate any of the flow. It simply passes the inputs directly as outputs, where the input would be the error. So this is why we can type it as such, and we're not going to get a type error, because unknown is the widest type there is, alongside with any, I guess, where if you were to type this as a string, you're going to get a type error because this layer doesn't fail with a string. So this is one workaround to get the type safety. And here we can use check, where we pass in a function. So here we can say input, and you also get access to the output, as we can see here. But again, identity passes the input, so we get back a config error or SQL error. And then we can say where this is an SQL error. And what this check will do is filter schedule executions based on a custom condition. So this function modifies a schedule by applying a custom test function to each input-output pair. The test function determines whether the schedule should continue or stop. If the function returns true, then the schedule proceeds as usual. If it returns false, then the schedule terminates. So this is useful for conditional retries. So by doing this, if we were to get a config error, then this will stop essentially. And what can we then do? Well, intersect this schedule. So we want and semantics. We wouldn't want or semantics. And we can say with an exponential schedule of 1 second as the base, and then we can intersect this with recurse 2, so 3 total attempts. And that's it, we're good to go. Now to test this, I'm not running the PG container, so I can simply filter and do a database migrate. And we're going to get the error here, but obviously we do not have any information as to how many retries or if it even retried at all. So for that, we can come here and say from or on decision, and we can pass in again a function, and this on decision is going to give us the output comma the decision. So returns a new schedule that executes an effect every time the schedule makes a decision. So this function must return an effect, and this is useful for logging. So as we can see, allowing additional logic to be executed, such as logging, monitoring, or side effects. And this is super handy. And in fact, we're going to use this for our LLM generations. So here we can again get the output and then the decision, and then we can check, is that decision.tag equal to continue? If so, we can do a log info saying retrying database connection. Otherwise, we can return an effect void, so don't do anything. And that's it. Now if I clear the terminal and run this again, we get retrying database connection, and after the 3 attempts, as we can see, we get the error, fail to connect. Awesome. And for last, let's do one more thing, and that is we can actually move this on decision to the very end. That way, for out, we get this tuple with a nested tuple, where we get the config error, comma duration, and then for the second element, for the root tuple, we get the actual attempt. So we can destructure this, so it is easier to work with, and we get the error here, we get the duration here, and finally we get the attempt. So we can modify this log to say retrying database connection, and then we can say duration dot format and then the duration, and then we can add a hashtag for the number attempt, and that's it. Now if we run this, as we can see, we get the number of the attempt. So we can actually say ++. So let's try again. So as we can see, we get retrying database connection, 1 second, and then number 1, and then 2 seconds, number 2. So we can say in, and then add some parentheses here just to make it nicer. Awesome. Now this looks much better. Alright, so this is pretty much it for this video. Now I know that in the last video I said we would be building out the API and whatnot, but I felt it was very important to first lay this foundation on layers, understanding why they are their own concept, how we can schedule, retry, and compose them. So now that we have that covered, in the next video, we'll put it all into practice as we actually scaffold the entire API. We do the database communication and wire everything together with a shared contract for the client. So I hope you learned a lot from this video. If you have any questions or even feedback, let me know in the comments. I'll see you in the next one. See ya.